We have enemy ships moving around the game world, but now we'll make them react to the player and fight back. The A-star algorithm lets opponents deviate from their path, hunt the player, and return to their mission if they disengage. Now that we can see damage effects in the HUD, we'll tweak the game balance to something the player can win. Let's review the AI slide in the design document. The new AI capability is tied to the hunt and path seek state. Most of the time the AI will be in the move state and following their predetermined path, but we want the combat ships to deviate and hunt other ships that get too close, such as neutral ships or the player. During hunting, the ship may fire at the target. When the target is destroyed or gets too far away, the ship should change to path seek and find a way back to the originally planned path. This is where A-star comes in. The algorithm returns a path between 2 points if one exists. We have a good heuristic in Manhattan distance when applied to a grid world collision map. We'll create a script and any ship AI object can call it. The script will fill a stack with the path that the AI ship can follow, one waypoint at a time. Now, I'm not going to discuss the theory behind A-star since Wikipedia does that well enough already. Let's go into GameMaker and get to work. Most of our important work will be here in the AI object. Let me open some of the script groups since I know we'll be adding several helper functions to support pathfinding. So under the initializer, I'll add a new variable for the AI timer, which I'll randomize. Pathfinding is sometimes expensive, so I don't want every NPC ship locked to the same schedule. Now we'll make some supporting variables and data structures. The ship will remember its goal. We'll have a priority queue representing all possible choices for the next step in the path. Then we'll have a list of path nodes we've already checked. We'll use a map to keep track of which nodes led to which others we've checked so that we can build a final stack with backwards traversal. The cost map keeps track of the frontier base costs. And finally, this stack will hold the final path. These next variables hold the x and y values of the next path point. So the next thing we'll need is a code block that selects the appropriate mode. And we didn't need this before because there was only one non-trivial movement mode. Now we'll isolate valid combat ships that will check for a target and change modes if appropriate. If the ship is already hunting but there's no target, then we'll move it to path seek so it can find its way back to its mission. If the ship isn't hunting, then we need to find a target. I'll use this script that I'll comment out for a minute. If there's a target, then it checks if that target is close enough, let's say within 30 map tiles. If so, then we'll clear out the stack and change to hunting. Then we'll need to reset the timer to a random amount before we check this routine again. Finding the closest enemy will be checking every ship for non-matching alignments and returning the ID of the closest one. We want the mode select to happen first every step. So if the ship is hunting, it should start by checking to see if the path is still valid. If it's not valid, or hasn't been calculated yet, then we'll need to run A-star to get a path. I'll pass the start and end coordinates and a length of 10 steps to search. Usually ship targets are moving, so searching the entire route is not efficient. I'll comment that out until I get the script working. If we have a good path, then we need to find the difference between our current position and where the path wants us to be. If we're already at the target waypoint, then we'll check the path for the next waypoint and make a new path again. This time I'll set a random location around the target because this case is likely to happen when we reach the target ship, for instance, and then we'll just sit there. Otherwise, we'll have more path to go. I'll comment that out again. Let's get the next waypoint. Now I'm going to be storing each map position as a unique number that I can convert to and from coordinates. I'll make a helper function to do that. Now it's as simple as giving a unique number to each of the 201 by 201 map points. The x-coordinate is simply the modulus of the ID, and the y-coordinate is the ID divided by the width rounded down. This next routine will look familiar. It's the same code block from the move AI that compares the path points and pushes instructions. I think I'll put firing directly in the hunting block and skip making it an actual state. If there's no firing delay and we're facing our target at roughly a 1 screen width, then the AI will fire. Now this is an unusual one. Remember that the ship doesn't turn if it goes straight backwards. Well, just to prevent the ships from flying backwards towards the goal, I'll throw in a random command to make them turn. Well, I guess it'll be right after a couple of tries. Let's uncomment the AI star lines and build that script. Now this is the heavy lifting for the video. So the 5 arguments we passed to A star were the 2 starting coordinates, the 2 ending coordinates, and the path length limit. I'll declare some as local variables. The first step is to add the starting node to the frontier. Actually, I think I'm already ahead of myself. The real first step is to clear all of our data structures. And we should get the unique ID of our goal node. Now, those unique IDs are simply multiply and offset. Actually, I think we already converted to row major from column major. Don't want to reflip the collision map. Then we'll add the first node to the frontier using its Manhattan distance from the goal as a weight. I need to define the Manhattan distance, which is simply absolute offset in both dimensions. We'll also add the node's relationship as the original parent, and also 0 initial cost. Then we'll start the loop. Now the overall idea here is to process the best frontier node, which adds new nodes to the frontier, and then to the close list. As nodes flow from the world to the frontier and then to the close list, we'll either hit our max steps or find the goal. Now I'm going to knock out this code block really quick and leave comments here. So after we have a path, we need to follow the relationship map back to the original parent node by adding them all to the stack. Finally, we'll set the calling object's next waypoint to the first point in the stack. That clears up the hunting routine. Now we'll move on to path seek, which is finding the shortest route back to the mission path. I'm actually going to copy the hunting routine and change some points. Like the scan distance, since this is a more rare occurrence, I'll make it longer. Also, we're now focused on the next fixed path point, not a ship target. We won't need firing this time around. We shouldn't need the reverse routine either. But I do want to add a check to see if we're near the fixed path. If so, we'll change to the move state. Alright, let's test. Oh, it looks like I had a typo for the waypoint. Okay, we'll try again. Okay, we're running. But something's wrong. I feel like someone should be chasing me already. Oh, something went undefined. All I can think of is that a ship was destroyed and the AI controller tried to grab its agent handle. We'll fix that by making sure when a ship is destroyed, it invalidates handles in the AI controller. Oh, there's another typo. There's still no one chasing me. There may be a problem with our states, but I don't quite know yet. I'm hoping we'll get rid of all the crash bugs at least. Okay, to test the state issue, I'm going to change the find closest opponent script to always return the player's ship. That should bring the heat on quick if the states are actually working. Or it brings nothing at all. Okay, let's bring out a big gun and make the AI draw a big pink line between the agent and the target ship, which is always the player now. Nothing. Absolutely nothing. So these ships must not be staying in hunting mode by the time the draw event is executed, and thus not drawing the pink line. But it looks like this ship does see me and is firing back, so I know they're at least hitting the hunting phase briefly. Okay, there's no target variable initialized, but that wouldn't cause this issue, just a potential crash bug. Ah, pathseek was actually checking for hunting and hijacking the state logic. Since ships are always on path when they change to hunting, pathseek immediately thinks they're on path and changes them back to move. This is generally why we avoid code duplication. The worst case is copy and pasting a large, untested code block. We tend to skip the gut check, and if there are bugs like this or a misspelling, well, we have to fix them twice. Shame on me. Now everyone is on me. But look at my shields. I'm invincible. Let's calm the opponents back down and do some balancing. Let's go to the actual game and look at the ship library. It has some data on ship shields, armor, and speed values. We'll just use those values and scale them as necessary. I like the speed of 5 that the player ship has now, so I'll add a scaling factor to get that value down to 5. We'll balance in the user-specified event. What's this? It's like the 10th bad reference on this test. See the yellow flash in the background? The enemies were hunting a neutral ship and destroyed it. I guess that destroy event didn't execute quickly enough. I'll either need to verify that the handle is valid before using it, or I'll make sure the destructor executes the moment the armor just drops to 0. I'll just add the check for now. I'll have to change the waypoint misspelling in the pathseek routine that we pasted in. Let's figure out why we're invincible. I went the wrong way on this check. If shields are below max, make them max. That's nice. We'll also add an agent check to the Hunt AI update. I hope we're getting close. Oh yeah, this is looking good. Almost dead. And I'm gone. Looks like the enemies are hunting someone else now. It's neutral transport. Okay, well, I'm satisfied with the AI for now. There's a lot of room for balancing and tweaking, but I'm just happy it's working, and it's difficult. Let's remove that pink line. Also, I'll tone down the AI a bit by making AI ships shoot less than the player. I'm pretty sure that's how it's done in the original game anyway. If the ship isn't the player, we'll add a random amount to the fire delay. And since these final changes are minor, I won't bother to test it out. So we've managed to get enemy ships making moves to stop the player using a well-known pathing algorithm. We spent a lot of time debugging my bad references and typos rather than the algorithm itself. We also added some balance to the game ships. Next time we'll start working on the logical framework of the mission so the player can return to base and advance the storyline.